Assalamualaikum and hi everyone. So good morning to every one of you. So today we are going to continue with part C for subtopic 2.1, which will cover ionization energy, limitation of Bohr's atomic model, and dual nature of electron. So the learning outcomes that we are going to cover in this lesson are we are going to calculate the ionization energy of hydrogen atom from Lyman series. Next, we are going to state the weaknesses of Bohr's atomic model. And lastly, we are going to state the dual nature of electron using de Broglie's postulate and Heisenberg uncertainty principle. So going on to the first slide, the question asks you, what will happen to the electron if it reaches n equal to infinity? So, to find that, you need to check the energy that the electron may have when it reaches n equals to infinity. So, at n equals to infinity, the energy can be calculated using E infinity equals to negative RH times 1 over infinity squared, and you will get the value equal to 0. So, what does that mean? So, that means that when the electron reaches n equals to infinity, the energy value will approach to 0. This means that the electron is no longer attracted to the nucleus, or in other words, we can say that the electron is already free from the atom. The electron is removed from the atom and the atom is ionized. So the energy difference between n equals to 1 and n equals to infinity is actually called ionization energy. How can we find ionization energy experimentally? So we can use the line spectrum. So ionization energy can be determined by detecting the wavelength of the convergence point. So this is the convergence point that we are talking about. So eventually, the line becomes so close to each other that merge at a point which is convergent limit, forming a continuous band. Okay, so bila dia makin tinggi, frekuensi dia makin tinggi, so dia punya line dia makin dekat. Okay, makin dekat, makin lama makin nampak macam dia form continuous band. Okay, so itu kita panggil convergent limit. Okay, so bila dia dekat convergent limit ni, bila dia approach n equals to infinity, the nucleus can no longer hold the electron. So now dia punya attraction with nucleus and electron dah makin tak ada. So the electron dah akan jadi bebas. Dia akan become free electron, and now the atom is said to be ionized. Sebab apa? Sebab the electron is completely removed from the atom. Okay. So, we can use the atomic spectra of Lyman series to find the ionization energy. So, in Lyman series, the frequency of the convergence of spectral lines can be used to find the ionization energy of hydrogen atom. So, we know that IE is equals to H mu. So, we substitute the mu infinity because kita ambil kira yang ni lah kan. Sebab dia dekat n equals to infinity, dia akan completely removed. The electron is completely removed from the atom. Alright, and here why we use Lyman series is because the frequency of the first line of Lyman series is larger than the frequency of the first line of the Balmer series. Now, we're going to look into the real definition of ionization energy. So by definition, the ionization energy, or the short form IE, can be defined as the minimum energy needed for the complete removal of 1 mole of electron from 1 mole of gaseous atoms or ion. And the unit used is kilojoule per mole. So maksudnya, ionization energy ni maksudnya the minimum tenaga yang dia gunakan untuk dia remove 1 mole electron daripada 1 mole gaseous atom. So kita boleh tunjukkan, we can show the definition using this equation lah. For example, okay, let's see. So maksudnya kat sini we have one atom. Okay, dia akan remove 1 electron untuk form gases ion. Alright, so dekat sini the energy that they needed to remove 1 electron, 1 mole electron from 1 mole of gaseous atom to form 1 mole of gaseous ion ni is IE. Okay, so the electron is ionized when electron is removed from the n initial 1 to n final infinity. Okay, sebab tadi kita bertengok yang sebenarnya kita punya energy difference between n equals to 1 to n equals to infinity is ionization energy. Okay, alright. So now, how can we calculate the ionization energy of hydrogen atom? Okay, so kita boleh guna formula ini. So kita tahu electron transition, okay, daripada n initial 1 ground state, dia pergi kepada n final infinity for complete removal. So kita tahulah siapa n initial, siapa n final. So kita substitutekan value ni dalam this formula. So you will get the ionization energy for or delta E is equals to 2.18 times 10 to the power of negative 18 joule. So this value is for the removal of one electron from one hydrogen atom. Okay. Tapi kita tahu IE maksud dia adalah energy untuk complete removal 1 mole of electron from 1 mole of gaseous atom. So kita kena cari untuk 1 mole sebab yang ini untuk 1 elektron sahaja. So untuk kira 1 mole, so for removal of 1 mole of electron from 1 mole of H atom, so we can multiply the delta E that we got earlier with the Avogadro constant. So you will get the delta E or the ionization energy here is equals to 1.3124 times 10 to the power of 6 joule per mole. But we know that the unit for the ionization energy, where is it? Here. Here is kilojoule per mole. Alright. So, kita akan bahagikan dengan 1000 untuk dapatkan unit kilojoule per mole. So, you will get 1312.4 kilojoule per mole. Okay, so this is the energy for the complete removal of 1 mole of electron from 1 mole of H atom. Yang ini tadi untuk removal of 1 electron daripada 1 atom sahaja. Okay. Now we are going to move on to the limitation of Bohr's atomic model. So previously we have learned about the 4 Bohr's atomic postulate. So from that postulate, we know that Bohr were successful in introducing the idea of quantum energy and explaining the lines of hydrogen spectrum. However, there are a few weaknesses and limitations in Bohr's atomic model. The first one, the theory that he possessed can only explain hydrogen spectrum or ions containing 1 electron. For example, hydrogen atom, helium ion, lithium ion, and so on. His theory could not be extended to predict the energy level and spectra of atoms and ion with more than 1 electron. Maksudnya kita hanya boleh tunjukkan kita hanya boleh predict energy level dan line spectra untuk atom ataupun ion yang ada 1 elektron sahaja. Okay, and lastly, dia punya model tu, Bohr's atomic model proposed that electron could only orbit at specific fixed distance from nucleus. However, that statement is completely wrong because the electron is actually so small that it could not travel in fixed orbit. Alright. So, to overcome the limitation by Bohr's atomic model, so de Broglie come out with his own theory. So, it come out with dual nature electron theory. So, French physicist named Louis de Broglie in 1924 said that electrons have dual nature, as both particle and also wave can be seen in an electron. So, what does it mean by dual nature? So, dual nature of an electron can be understood by that, like electrons too have a dual nature or property. So when an electron moves, it can be considered moving as a particle and also as a wave, both at the same time. Alright, so it's stated here also that small particles like electron can pass with nature when they are in motion. And if an electron behaves like wave, the energy and the wavelength must be quantized. So de Broglie come out with this formula where they combine the formula of Einstein punya formula back in 1905 kan, Einstein ada keluarkan satu formula yang paling popular, which is mass energy equivalence equal to E equals to mc squared, dengan formula energy of photon E equals to h mu. So dia broadly, dia assume yang these two energy dia punya value dia sama, dia ada same trait, dia sama lah value dia. So dia gabungkan these two equation to get mc squared equals to h mu. So so kita tahu mu sama dengan C over lambda. So bila kita rearrange the equation, so we can have lambda is equals to H equals to MC. Okay? Okay. Now, secara realistiknya, kita punya particles or electron, dia tak akan ada velocity of speed of light C. So, dia tukarkan sin jadi mu lah. Velocity meter per second. Okay? So, this is the final formula for de Broglie postulate. Lambda is equals to H divided by mass mu. So where H is equals to Planck constant, m is the particle mass in kilogram, mu is the velocity in meter per second, and lambda is the wavelength of matter wave. Okay. Alright. However, okay, walaupun kita dah walaupun de Broglie dah keluarkan dia punya teori yang memberitahu yang kita punya elektron ni dia boleh dia ada dual nature lah. Satu as a particle, satu as a wave. Tapi dia still tak kita still tak boleh tahu elektron tu dia ada dekat mana dalam atom tu. Betul tak? Okay, dia bercanggah lah dengan Bohr ni. Sebab apa? Bohr cakap elektron ni dia cuma orbit dekat specific fixed distance from nucleus. Maksudnya dia macam tahu dekat mana nucleus tu berada. Walhal sebenarnya kita tak boleh nak tahu pun dekat mana elektron tu berada. Okay, sebab of the uncertainty principle. So, we cannot assign fixed path for electron. We can only know the probability of finding the electron in a region of space, or which we call it orbital. So, kita boleh nak tahu dekat mana exact point elektron tu berada dekat mana dekat atom tu dengan cakap, oh dia mesti ada dekat this orbit, dia dekat fixed orbit. No. So, dia ada uncertainty principle dekat sini. Kita tak boleh nak tahu dekat mana sebenarnya elektron tu berada. So, jadi Heisenberg ni dia keluarkan satu principle. So, kita panggil dia Heisenberg uncertainty principle. So, German physicist Werner Heisenberg stated that the position and the velocity of a particle such as electron cannot be measured exactly at the same time. So, kita tak boleh tahu dia punya position dan dia punya velocity of the electron moving tu kat mana. Okay? So, in other words, it can be said that it is impossible to know simultaneously both the momentum and the position of a particle with certain. Or we can state it mathematically as delta x times delta p is larger or equal to h over 4 pi, where h is equal to Planck constant and delta x is equal to uncertainty in measuring the position, and delta p is the uncertainty in measuring the momentum is equals to delta m mu. Okay, so that is all for subtopic 2.1 Bohr's atomic model. So we are going to continue with the second subtopic, which is 2.2 quantum mechanic model in the next video. Alright, so we'll see you in the next video. Thank you very much for watching this video. Assalamualaikum. Bye.